Hello ladies and gentlemen, we're moving on to our Unit 2 now. So this is 2.1 Day 1. We're going to be graphing equations using an XY chart. This unit's going to be mostly about graphing and things of that nature, so here we go. Okay, we're going to be using an XY chart to graph equations that are in Y equals form and equations that are either in X equals a number form or Y equals a number form. Well, let's get rolling here. Okay, our question is, if a custom t-shirt company charges $50 for setup fee for any order and then charges $5 per shirt, what's the total cost of ordering various numbers of shirts here? Well, for 4 shirts, well, first of all, we have a setup fee of $50, and then we're going to add to that $5 per shirt, and we have $4, so basically that's doing 5 times 4, and crunching the numbers there, that's really 50 plus 20, so that's going to be $70 for that. Alright, for 10 shirts, we have a similar sort of process here. I got my $50 setup fee, and then I have my $5 per shirt, but this time I'm doing 10 shirts, and 50 plus 50 is going to give us an even $100 for 10 shirts. Alright, well, what if we go nuts and go for 60 shirts? Well, again, a very similar computation. 50 plus 5 times the number of shirts again, but in this case it's 60. Okay, now 5 times 60 is going to be 300, plus that 50 is now, we're talking $350. Alright, so let's put that to maybe some better use. Alright, so notice how those computations are a little repetitive, so hey, can we get an equation for this situation so we can have something we can use over and over and over? Well, the answer is basically a big old yes, but realistically I want to do more than just say yes for that. I want to actually get the equation. Okay, now notice each time we ended up with a total cost, and we could use any letter we like for that. We could use a capital C for total cost, and each step of the way we took 50 plus 5, and then when we multiply that by was the number of shirts. Now I'm going to use a cursive S for that because my S's look a lot like 5, so I'm going to do that to hopefully show the difference between the two. Alright, so basically there we go. And, sometimes it's better to have a picture, because if you have a graph, quite honestly, sometimes you can read things off the graph that make things a little easier to deal with. Alright, so for instance, we had 4, and then we had 70, we had a 10 and 100, and then we had 60 and 350. So if I think about numbers I could put here on my basic C-axis, whereas this is my S-axis for shirts, and then C-axis for cost, well, if I put something up here around 350, alright, and maybe I can do this by counting by 50s, so that'd be about 300 down there, that'd be about 250, that'd be about 200, that'd be 150, that'd be 100, and that'd be about 50. So there's 50, there's 100, there's 150. This is maybe not perfect, but hopefully you get the point. 250. Could I write any smaller? If you're watching this on your phone, you're probably having a hard time with those numbers. But anyway, I've got 470. 470 would put me about right there. 10, 100 put me about right here. And then when we went all the way to 60 and 350, that put me right about here. Okay, now if I graph this anyway somewhat accurately, these three should all line up with each other, and I admit I probably was a little bit off, but you can imagine I can have this nice little line here that goes through all 3 of those points. And basically what that'll do for me now is if I have any other value that I want for shirts, I should be able to read up and then over to find out the cost instead of having to do that computation over and over. Basically, point being here that sometimes graphs and lines can be very, very useful to help shorten up us figuring out some stuff. But here we go. Okay, to get the whole point across what we're trying to do here, no pun intended, how many points determine a line? Okay, now I have a lot of people tell me a lot of different things here normally, but if I have 1 point, I can certainly draw lines going all kinds of different directions through here, so it definitely isn't 1. But if I have a second point, okay, if I try to draw a line and hitting both of those, there's really only one way to pull that off. Okay, again, if I'm talking about line, by definition in mathematics, it's definitely got to go straight. So we can't have anything curvy here. Anything's going to be dead on straight. So basically, how many points determine a line? The answer is a clean 2. As soon as I have 2 points, there's only one line I can draw through there. Okay, however, how many points are represented by a line? As soon as I draw this line, okay, I don't only represent 2, I represent actually an infinite number of lines because I've got these 2 points that I kind of did, but I can imagine more and more and more of these points over and over and over. So how many points are represented by a line? Infinity. Okay, and in case you weren't sure, I put these arrows on the end because that arrowhead means that this line goes forever in both directions. So not only do I have the lines I can plot within this little region right here where I've actually drawn, but because of this arrow, it implies that this thing goes on forever and ever and ever this direction, and forever and ever and ever, and ever that direction. Again, give me more and more points that I could plot if I really wanted to. Alright, so let's get to the gist of what we're actually going to be doing today as per the objective, which is graphing using an XY chart. And the first thing I want you to do is pick several, and by that I mean at least 3, x values. Okay, now you might be thinking, hey, you said 2 points determine a line, and I agree with you. But if I only pick 2 points, for instance, if I pick this point, and let's say that I'm wrong with the second one and it ends up right here, I have no idea that it's wrong. But if I pick a third one, and let's say that point ends up right here, well, clearly this does not make a line, it makes some kind of a triangle. So by picking 3 points, if I make a mistake, it'll kind of show up as something that doesn't line up. So then maybe I can check my work, or maybe pick a 4th point. If I pick a 4th x value for a 4th point, and I get something there, and these 3 line up, I can pretty much say, oh, okay, that guy must have been bad. I'm probably good with those 3. So again, I'm making you pick 3 just as kind of a way to check yourself in case you make any mistakes. Alright, so anyway, I want those 3 x values, and then we're going to plug those values into the equation, and then basically solve for y. Okay, and once we do that, of course, I'll have an x that I picked and a y that I figured out, so that'll give me an x and a y, which is enough for a point that I can plot. So that's basically step 3, plot the points on the graph, and then we're going to draw a line through the points, and as I said earlier, it should not curve. We're doing lines, so it should be nice and straight. Okay, and again, as I said earlier, put arrows on the ends of the line and show it continues forever in both directions. Okay, those are the steps we're going to follow. Let's try a few out. Alrighty, here we go. So let's graph y equals x minus 2. Okay, now it's a relatively short equation, not too many bells and whistles on this guy. Alright, so first thing I'm going to do is I'm going to pick at least 3 x values. Alright, now some x values are messier than others. I'm not going to pick decimals or fractions unless I really have to. And I'm going to pick, honestly, relatively small numbers. I want to pick numbers that are going to fit on the graph that I have. So, for instance, I'm not going to pick x as like 25, because my grid doesn't go as far as 25. And honestly, what I'm going to do is I'm going to pick relatively small numbers. My preference, unless there's something else that'll change my mind about it, I'm going to just pick 0, because 0 is a nice easy number, 1 is pretty easy, and 2 is also pretty easy. Okay, now you don't have to pick these 3 numbers, but I just think they're easy to work with. And then, basically, again, we're going to just plug these into the equation and solve for y. So for my first one, my 0, I get y equals 0 minus 2. And of course, that's negative 2. So basically, now what I'm going to do is take that negative 2 and write it back here. Okay, basically repeat that with the other 2. Y equals 1, the x that I picked, minus the 2, because that's part of the equation. 1 minus 2 is negative 1, so I write the answer there. And again, just continue with this. Y equals 2, the x that I picked, minus the 2 from the equation. 2 minus 2 is 0, so I put a 0 right there. Okay, and again, this is giving me 3 points. And now I just have to plot them. If I had to plot 0, negative 2. Okay, now be careful plotting your points. Remember, the first one always goes left or right. The second one always goes up and down. So if I go 0, negative 2, I go 0 left and right, and then down 2, and there's my first dot. Okay, now I go 1, negative 1, that's 1 to the right, negative 1, which is down 1, and there I am. Okay, now again, that's just 2 dots, but if I made a mistake, there's nothing really to tell me that yet. Now by my third point, 2, 0, I go 2 to the right, and then 0 up, which puts me right here. And again, now I look at those 3 and think, hey, those are pretty straight, so I feel pretty good about what I've done, and I can draw a nice line with arrows on the end, and that's what I'd be looking for from you. Alright, taking a look at another one, a little bit more interesting equation. Got an extra number as well, so I'm going to go on and pick my 0, 1, and my 2 again, and again, same basic process. Y equals negative 4 times 0 plus 1. Okay, crunching the number here, 0 plus 1 is 1. Picking the 1, or plugging in the 1, I guess I should say. Negative 4 times 1 is negative 4, plus 1 is going to be a negative 3. And then for the third one, negative 4 times 2 plus 1, so I've got a negative 8 plus 1, which is a negative 7. Okay, again, plot these points. 0, 1 is right here. 1, negative 3, 1, 2, 3 is right there. And then again, as long as this one lines up with the other 2, I should feel pretty good about what I've done. So 2 to the right, and then 7 down. 1, 2, 3, 4, 5, 6, 7. There you go. I think those look pretty darn straight. So I'm feeling good about life in general. And there's my line. Now, you may not be a big fan of this, but a fairly common thing we're going to have with our equations is fractions. And if your equation has an x to the fraction for a coefficient, which is, again, that's the number in front of the x, your best pick is pick x values that are multiples of the denominator. And this is going to avoid fractional points for us. Okay, so for instance, your equation is y equals 1/5 x plus 3. Again, I'm looking at my denominator now. So I'm looking at that 5 and thinking, okay, what are multiples of 5? Okay, now first of all, one thing that most people don't think of when they think multiples is 0. And 0 is actually a multiple of every single number, which is kind of nice. So a number I can always pick is 0. Okay, and then multiples of 5 from there, most people probably started thinking 5, they started thinking 10. But one thing you can do if you wanted to is actually go the other direction. So you could pick negative versions of these guys. So we could pick -5, -10, whatever. Okay, so there's some good numbers you could pick, of course, if you wanted to go on to 15 and so, but again, once you start getting too big, they probably won't fit on the graph anymore. So you probably want to stick to the numbers that are 0 and numbers close to 0. Okay, just as a second example, if your equation is y equals 4/3 x minus 7, again, I'm going to key off of the 3. And again, I'm going to include 0, because it's a really, really easy number to work with. In this case, I would do 3, 6, 9. Again, 12 is probably too big, so I'm going to stop there. And if you wanted to, you could go with negative versions of those guys as well. Okay, but again, me personally, I would probably stick somewhere between the -3 to 6, because those are just kind of nicer numbers. Alright, so let's look at one of these guys. Alright, y equals 2/3 x plus 5. Okay, now again, I'm going to pick multiples of 3, and the easiest one to work with is 0. Now, basically, again, I have, from what I said in the last one, I have choices between like -3, 0, +3, 6, etc. And given a choice between 6 and -3, well, you, me, everybody, we make less mistakes with positive numbers than we do with negative numbers. So, given this scenario, I would pick 0, 3, and 6. So those are the 3 I'm going to slide here into my XY chart. Alright, so again, I'll start plugging them in one at a time. 2/3 times 0 plus 5. Again, I'm a huge fan of 0 because anything times 0 is 0. So this is an easy one because this is 0 plus 5, so it's 5. Alright, then unfortunately I've run out of super nice numbers, but again, 2/3 times 3 plus 5. Okay, now if I do 2/3 times 3, what's really nice is the 3's actually cancel and leave me with a 2. So what I really have is 2 plus 5, which is 7. And then lastly, I've got 2/3 times 6 plus 5. And the 2/3 times 6, well, the 3 and the 6 kind of reduce down to a 2, so I'm left with 2 times 2, which is 4. 4 plus 5 is a 9. Okay, if you don't believe me, please plug that in a calculator and double check me. Okay, but again, I've got 3 points, and as long as I plot them and they look straight, I should feel pretty good. So 0, 1, 2, 3, 4, 5. And then I go 3 over and 7 up. And then I go 6 over and 9 up, with me right there. So granted, we have one that's really high up on a graph, but it definitely does fit, and the lines, or the 3 points ended up being straight, so I draw my line and feel good about life. Okay, now remember in the objective, there's 2 unusual cases to watch out for. In the objective, I mentioned the x equals number and y equals number possibilities, and basically, there's our weird cases. Okay, now again, I'm graphing y equals 3 now. Okay, notice we've got away from the fraction, so I have to worry about picking multiples or anything anymore, so I can go back to picking relatively nice numbers, or honestly, any number that I felt like. Alright, so now here's the weird thing. I'm going to pick my 0, I'm going to pick my 1, and I'm going to pick my 2 again. Okay, well, so now I'm going to plug in 0 for x. Well, if you notice, there's no x to plug into. So I basically just can't, and I still get y equals 3. So 3. Again, if I try that with the 1, I still can't plug it in anywhere, so I'm still just left with 3. And I repeat that with the 2, and again, since I can't plug anything, I get 3 every time. So I've got these 3 points right here, 0, 3, 1, 3, and then 2, 3. Notice that they just give me a nice little horizontal line. So there you go. Wow, that was sloppy, but hopefully you get the point. Alright, now the x equals is actually even weirder. Now here's the deal. Okay, normally I pick whatever x's I want, but notice here, by basically writing this equation, what I'm saying is x has to be -6. I don't have a choice for my x's, so I'm stuck at -6. Anything I can imagine, nope, -6 every time, for this particular case at least. So since my x is locked in, basically what I have to do now is choose y's. And the good news is I can choose anything I like. So I can choose 0, 1, and 2, those same 3 very, very nice numbers I've used for x's in this particular case. So when you have the x equals, here's how I remember it, is the exception to the rule. Okay, it's the exception. I can't pick my x's because I'm locked into a particular value. So I stick that value in the x's and then I pick whatever y's I want to use. That's why it's the exception. Hopefully that makes sense and it's not too bad of a pun, but here we go. So now I'm going to plot my negative 6, 1, 2, 3, 4, 5, 6 in the negative, and then 0, negative 6 to 1, and then negative 6 to 2, and notice this gives me a nice vertical line. Okay, one thing I kind of encourage you to do is just kind of memorize that if you have y equals, it's going to be horizontal, and x equals, it's going to be vertical, and then it saves a whole lot of trouble later on. But you're free to do it any way you like. There you go. Alright, for today's video, we've got 2 pages worth of try these, so here's the first one, and here's the second one. Okay, so please give these a shot, and I'll see you in class.